Dr. D.
Hi guys, what's up?
We felt our treehouse shake this morning and wanted to know what happened.
Yeah, I felt something too.
We think that it might have been an earthquake, but we can't prove it yet.
Have you ever been in an earthquake?
Yes, I have. But it didn't feel the same as what I felt this morning.
See, I told you it wasn't an earthquake.
Well, wait a minute. All earthquakes don't feel the same. To begin understanding earthquakes, you have to know something about the structure of the earth.
That makes sense. What can you tell us?
Come on, let me show you.
Okay.
Let me cut this peach in half.
Okay, be careful.
I will, thanks. This will be our Earth.
Only it's a lot smaller.
It's called a scale model. The pit is like the core of the Earth. The Earth's core is about half of its diameter.
What's it made of?
We've never been there, but we think it's made of iron and nickel. The inner part of the core is solid, and the outer part is liquid. It is so dense, if we had a gallon jug full of the Earth's core material, it would weigh over 100 pounds.
Wait, Dr. D, you lost me. How do we know how big the core is and what it's made of if we've never been there?
Well, it's just a guess.
You're kidding.
Well, actually, it's a pretty good guess based upon a lot of evidence. One of the biggest clues we have to the structure of the Earth comes from our study of earthquakes.
So we're using earthquakes to help us understand earthquakes?
That's right. The part of the peach that you eat is called the Earth's mantle. It's not as dense as the core, but it's more dense than what's on the outside.
What's the outside called?
It's called the crust.
Just like the crust of a bread.
Very good. Like the skin of a peach, the Earth's crust is very thin. The crust under the oceans is typically between 5 and 10 kilometers thick. It's made of a dark, dense rock called basalt. The continental crust is between 30 and 70 kilometers thick. It's made of a lighter, less dense rock, like this granite.
Is there a reason why the Earth is layered like this?
It's because of density. Watch this experiment over here. I'm going to put this green-tinted water and this salad oil into this graduated cylinder and then shake them up. Let's see what happens.
The salad oil is on top, and then the water.
Let's put in some motor oil. It turns out the least dense, which is motor oil, floats on the top. And the most dense, water, sinks to the bottom. It's just like the early history of the Earth, when it was all liquid.
Earth? Liquid? Strange, but what does this have to do with earthquakes?
When the Earth cooled, the crust upper mantle became rigid and brittle. They broke into about 12 segments, which we called plates, kind of like this cracked boiled egg. These plates float on the more dense but flexible mantle below, kind of like this egg white. These plates are in continual movement.
Wow, this is too weird. Why don't we feel them moving?
They move about as fast as your fingernails grow, which is only a few centimeters per year. But we have fossil evidence of this movement, which we call plate tectonics.
Are fossils also clues to understanding earthquakes?
Well, yes.
But Dr. D, aren't there other things that could cause vibrations?
Well, yes, that's a good question. Anything that makes a very loud sound can make things shake a little.
I watched fireworks on the 4th, and some were so big, I did feel a vibration.
Oh no, I'm late for an appointment. Why don't you stay for a while and discuss this amongst yourselves?